our recording. Then we will start our lecture. Okay, so first let's just do, we already finished all of the examples, is it, about Java collection, if you recall last week. And Java collection is, there are a lot of quite useful data structures that we already learned. And we have some chat question. Okay. Yeah, okay, you guys want to discuss the lab. Yeah, I can do that tomorrow. Okay, yeah. Okay, so so let's just do a quick review. Okay, and especially for Java collection, make sure you understand the collection hierarchy. Yeah, the collection framework hierarchy. Okay, so and if you recall, collection also extends from iterable, is it? So iterable kind of like the top level of interface, is it? Then we have collection, is it? And under collection, we have list and queue. Both are also interfaces. The DAG is also interface. So all these three are interface. Okay, and of course, these two are also interface. Okay, so remember this. Okay, and we didn't discuss any of the, so in the middle of this part, it's all about abstract class in collection. And we didn't discuss any of it, okay, because we used quite a lot of the concrete classes, the linked list, array list we learned, stack we learned, and the priority queue, that we discussed all of that. So this is the hierarchy, is it? And iterable, if you recall previous, we also did quite a number of examples discuss iterable, is it very useful? And we haven't really discussed collections, so let's take a quick look of the collection. And the collection, so this is the textbook slides regarding Java collection. Okay, and it is from Java utility package, is it? And we have this collection interface, and here it lists of the methods, is it? Like over here, the add method. So add a new element to this collection, is it? And you can also do add all, is it? And if you take a look at this add all, and let's go to the official document to discuss. So here, anyway, it's just a list all of the methods, is it? And in this diagram, you can also see, is it, the iterator interface. Previous, we also learned, is it? Okay, so let's get back to the official document. So I'm going to start to share this one. Then we can have better understanding. Okay, and I also recommend you to take a look those Java official document. So this is regarding the collection, is it? If you take a look here, it says, okay, java.utility, is it? And it's an interface, and it's also a generic one. They give you the full description, is it? And it also says, oh, it's a super interface, is it, from iterable, is it? And also list of the sub interfaces, is it? There are quite a number, is it? But we already learned DAG, list, is it? Those are the two of the ones we learned. And it also says, okay, all known implementing classes, is it? Which class implement? Here it lists quite a number of it, is it? Because anyway, the collection is kind of like the root, is it, in the hierarchy. That's why over here you can see who implements, is that if we take a look, if we recall linked list, as we learn stack, array list, where is array list? Yeah, array list. We also have array DAC, is it? And what else? Oh, priority queue. That's all we learn. Is that implement this interface. Okay, so then within this official document, you see to give you quite a detailed description, is it? So it says a root interface in the collection hierarchy, is it? Yeah, and give you a lot of detailed description. So if in the future you going to use collection library a lot, you can refer this official website, give you the detailed description about this collection interface. Is it? Then here to list of the methods. Is it here to list this add method, what it return? Is it? And what does it do? Is it? And here it says, okay, add all. If you recall, add all, it's add another collection, is it, to the specified collection you want to add, is it? So if you take a look at the parameter type, did you see it's a collection, is it? Collection. And we already learned this previously in the generic discussion. Is it? So this is what? Is this? So here is our first quiz question. So what do we call this? Is this generic or something else? The question mark. Who remembers? Okay, let's see. We have someone knows. Yeah, it's a wild card. Okay, very good, very good. So this is a wild card. Okay, so kind of remember this. We previously learned it and also quite useful. Okay, and then here it's also that's like contains method, contain all, is it? If it has another collection, is it equals, is it? And the hash code we haven't learned, okay. And the empty function iterator, is it because of the iterable interface? Is it? And the remove method, is it? And you can also do remove all. Is it remove all and retain size? Is it? Some of them we didn't learn. And if you recall, we also learned that stream, is it? But over here it says default. So who remember what does this default mean? What does it mean here? So this is default. This stream method is that it's called the return type is a string, but it has a default ahead of it. What is that? So this is our second quiz question. So who remember? What does this default mean? Who remembers? So what's the difference? Why you say to array method, it doesn't have default. This to array doesn't have default. Why that method has a default? So here, let's see, do we have anyone answer this? Not yet. So who remembers? What does this default mean? Okay, so someone answered, is it? And this is what? This is called a default method. Is it? Default method is what? It's already implemented. Is it? It's already implemented. And this to array is called its abstract method. Is it? What's the difference between default and abstract methods not implemented. Then who is going to implement it? Concrete class. Is it going to implement it? That's what an abstract method means. This is default. Default method is already implemented. Okay, so be careful. And this string, it returns what? It returns a string. Okay, so that's this.
Question about,
yeah.
Like, so okay. I'm kind of confused. I don't know if everybody else is. So we have wildcards, and then we have generic type. So we have those carets and just E. What's the difference and how can we use it?
If you recall, for this for the generic type, if you said T, is it? And when you use it, then it got to be this specific T. You see, suppose if you have a method function, is it a function, and it's some generic type. Suppose it's list T, and you call air, is it? And suppose you have two parameters. Okay, one is list T, the other we call it Q. T, Q. Okay, then when you pass in, when you call this function, then you got to have, you got to suppose we pass in new linked list, and suppose it's account A. Okay, and the other one there is going to be new, and because it's Q, is it? So I also call linked list. Then in this case, it's also going to be account.
Okay, so we use carets for the structures like linked
so
list,
you
array list,
then,
queue.
Pardon me, then it needed to be specific. You know, both of this in this case got to be the same. Is it account? Is it? But if you change it to wildcard, then maybe this can be account, the other can be employee. Is it? So wildcard doesn't mean then in this case, these two got to be the same. But for generic type T, even though it's T, but when you call this got to be exactly the same. That makes sense?
Yeah.
So that's the subtle difference. Yeah. Okay, so that's regarding this. We already kind of done off the methods, is it? And method detail, if you want, you can take a look. Is it here? It gives you all the method detail. So anyway, so this is regarding this collection, is it? This collection interface. Then if you take a look here, is it? It's a sub interface. We are kind of interested in list, queue, and the DAC. Is it? We use this. So let's take a look of this three. So I'm going to go to list. So can you see the list right now? Can you see? I'm not sure if on your end it's also see interface list.
Yes, we do.
Yes.
Oh, okay, very good. So you see this list is also an interface, is it? And it lists its super interface. Is it collection iterable? Is it? And it doesn't have any sub interface. So it's a list of the class who implemented. Is it linked list stack? Is it? We already see that. Is it over here? So linked list implement list. Is it stack also implement list and vector? Is it? Okay, and then let's take a look more. So what over here says basically is it when you define this list interface, you define kind of like this. Is it okay? Public interface list and extends collection. Is it? And what it does is the list, it can be used for ordered collection. Okay, ordered collection, it says also means some sequence, is it? And the advantage of it is that the user of this interface then has precise control over where in the list each element is inserted. Okay, as a user also can access by the integer index and search for the elements. So it gives you more detailed description about this specific interface list. Okay, and then we can take a look. Did you see over here? It also has why I cannot do annotation. It also has the add method, but it has another add. You remember this is from collection. Is it from collection? And this is its own. This is lists. Collection doesn't have that. Is it? So you can also specify exactly where you want to insert. Is it where you want to? And add all, it's also from collection. Is it? But here you see this, you can also specify where you want to add all. This is specific to list. Is it? So it has more abstract method as it contains or equal. And did you see it also has that retrieving as a get method. Is it? And it also can give you the index of, is it? So where the item is. And iterator, it also gave you, if you take a look, is it last index of certain specific object, is the first index, last index, is it? And give you list iterator, is it? And list iterator. And this also allow you to do two-way iterating. Is it not just forwarding? It also allows you to do backward. Is it? So this is this why? Let's double check. Okay, and we also have remove method. Is it? And yeah, over here you see it also allows you to do set operation. Is it? And here for sort, if you take a look, the sort method is what? It's a default method also. Is it? Okay, so this is regarding list. Okay, list. And list, we get it. And let's go to take a look, queue. Okay, the queue interface. So queue, what it says, okay, its sub interface is DAC. That's all we learned so far. Is it? And then over here, for queue, if you recall previously we said add at the back. So add at back and remove at front. This is what defines queue. Is it? It's FIFO. First in, first out. Did you see over here it says all the element in FIFO. Is it? And here it's the major important operation for queue method. So you can add at the back, is it? Remove at the front, and you retrieve. Okay, but we have two sets of such methods. So you can choose. If you want to add the back, you can also do offer and the poll and the pick. So the difference between these two is if you want to do it, in case there's any error for add, remove, and elements through exception, if you recall last week our example, is it? And for this set, it returns some special value. We call it null value, is it? If you recall last week's example. Okay, so that's a major difference between these two, okay? To say, because sometimes you may want this case, the other time you may want the other case, okay? And over here, it shows, is it like for this ad? And it can throw, it called illegal state exception if there is no space available, okay? And for this offer, as it offer says, and so this offer, it returns Boolean, so if you can add or not, okay? And over here it also lists pick, pull, remove, etc. So let's see, there are more discussions here. Says like add all clear, so quite a number of methods is anyway inherited from collection library. So it didn't list all of them like in the collection interface. Okay, and here it also gives you the detailed description about each specific method. So in case when you write a program, okay, if you need a detailed understanding of a specific method, then you can refer to Java's official document. Okay. So this is regarding Q. Then let's take a look at DAC. Okay, and for DAC, so who remember the difference DAC versus Q? What's the difference between these two? Who remembers? DAC is,
access,
yeah, please.
You can access elements from both sides in DAC.
Yeah, DAC is called double-ended queue. Okay, very good. So you can add and remove at both ends. Okay, not just one end. Okay, so that's a major difference between DAC and the queue. Okay, and here it says, okay, it extends from Q, is it? And over here, it also shows us, the major method, is it? Major method regarding front and regarding last element. So sometimes you also call it a head or tail, okay, head or tail. So you can throw exception or give some special value, so that's a difference. So over here, it's not just add at the back, is it? So you can also add first or call it offer first, is it? Remove first and pull first, and gather and pick first, or add last, offer last. So it has specific first and last in the method, okay? So that's also quite useful, is it? And here it gives a comparison of Q and DAC, the corresponding method, okay? And also compare DAC with stack, is it? Because DAC also kind of has some of the features regarding stack, is it? And over here, the list of the method in detail, okay? So if you're interested, you can refer more, okay? And next, let's take a look at linked list. Okay, linked list, we already see it a lot, is it? So here it says the complete code kind of in linked list definition is public class extends abstract class and implements list DAC as a clonable and serialized. And all these three we already learned, is it? Okay, and then next, let's take a look at the linked list, what it has about. So linked list over here shows there are two constructors because this is a concrete class. So it has two constructors. One is without any argument, so this creates an empty list. The other one, you can also create a linked list with another collection, is it? With another collection. So here it says containing element of the specified collection. Okay, so it's another linked list, is it? Or like array list. So anyway, anything that that implements collection. That's why over here you can also kind of see, is it, why we have this kind of a hierarchy. Is it? That makes it more flexible. That makes it more flexible. So in this case, it's just any class, any concrete class, which implements collection interface. Is it? Then you can plug it in. Maybe even someone that you define, that you can also plug in. That's what this parameter means. Okay, so that's, and over here it also list of the method, is it? So the add, is it, and add all. So over here it's all implemented. Versus previously what we saw, those are not implemented because they belong to some interface. So over here it's all implemented, okay? And add first, add last. You can clearly see it's more than collections or list, is it? So it has more. And the clone and the contain, is it? And the iterator and element get, index of, last index of, list iterator, is it, offer. So a lot of method, is it? Okay, so this is regarding linked list. And let's see, I may need to go back to, this is Q. Let's go back here. And let's find array list, take another look. Array list here. Okay, so here is the array list concrete class that we have already learned. So if you see, it says implements list, extends from abstract list, is it, and the corresponding other interface. And here it gives you detailed description about array list. It says it's resizable array implementation of the list interface. Is it? And over here it says this class provide method to manipulate the size of the array. Is it? So it's more associated with array, okay? And previously we also discussed the difference between array list and linked list and their advantage. And over here it also gives you array list constructor. So empty one, similar as a linked list, another collection that, and you can also initial with some capacity because anyway to use array. And over here, it also gave us an add, and add all, clear, clone, contains, and for each method, get, index of. So quite, so it's, there are a lot of similarities between this and linked list. Okay, so that's regarding the document. So I'm not going to discuss all of the documents, okay? But anyway, you kind of already have some idea, okay, how you refer the official Java document about a specific collection interface or specific collection class. And over there to give you the full description about the interface and the class. And what next we are going to take a look is the implementation of linked list. So this example is try to kind of mimic what linked list is implemented in the collection, okay? But it's not exact the same, okay? Kind of give you some idea. And as to how the linked list is really implemented in collection, you can always find its original source code. Okay, so next let's take a look at this case. So this time, what we are going to see, if you take a look, so this example on our course website is called LinkedList. And I have 3 files. I have I call it MyList Java. And then I have one called MyLinkedList.java. And then I have that linked list. Okay, so I have 3 files. So let's first take a look at this MyList. If you take a look at MyList, oh, sorry, I needed to get to this. So now so I want to check with you what you saw on your end. What you see is it called public interface MyList. Are you all seeing the same as me?
Yes.
Oh, okay.
Yeah.
Okay, so over here, I'm trying to define a list interface. So I call it MyList, and it's a generic one, is it? And it extends the collection interface. Okay, then over here, did you see I define this abstract method? This abstract is that I'm going to add a new element at the specified index. So this one I'm trying to mimic the list, official list interface in Java collection, okay? So that you can have some idea about how the collection framework is coded. And then we have this get method, so it's abstract. So all these are abstract methods in this interface definition, is it? We haven't implemented yet. So it's just a method prototype. That's what we provide. Index of, same thing, it's just an abstract model. Last index is just as a method prototype, remove, set. And then here we said, okay, I want to define an add method. A method return type is Boolean. But did you see I said I define it as default. I define it as a default method. And if you take a look how I implement it, I implement with call add method. And if you recall, the add method over here, it has 2 parameters. The first parameter is the index. The second parameter is the item you want to add. And this is an abstract method. So not implemented yet. We saw that method. Then over here, for this default method, then I call abstract method. You may say, oh, how weird this is. Because that method is not implemented, but that's okay. You can call it. Okay, so this is the default method. Then I call the abstract method in this specific interface. And I want to add at the back. That's what I define here. And if you take a look at this empty method, it's the same. I defined it as default and I did implement it. Is it? Okay, then let's take a look at some other things. So remove method, same thing, I defined it as a default method and then I implement it. and contain. And over here, I said I just leave it as exercise. And after class, if you are interested, you can try to complete all of this. Okay, right now I just leave empty. Okay, and this two array method. Let's take a look here. This two array method, what we implement, we also implement the default method. And what I did is, okay, I first create an array of object, then I cast it to the generic type. Is it? And what I did, I call the get method, is it? And assign it to the array, is it? And I return it. That's how I implement it here. So over here, this array method I implement, and the other array method I also implement. This, if you take a look at the difference between these two, for this array, two array method returns an array of object. For this one, what it returns is an array of the specific type, is a generic one. Okay, so that's what, anyway, this interface. So within this interface, I have abstract method, I also have default method, kind of like the list in the library. Next, let's take a look. This is my linked list. And this my linked list, if you take a look, it says it implements that list I just defined. And over here, I do have the node, is it, as the instance variable. And for this version of linked list, I have both a head and a tail, the node. And I also have a size. So I have 3 instance variable in this case. And then let's first take a look at that node class. If you take this, is much more complicated compared with previously the way we implemented for our linked list. Okay, for this node class, is it? And we have the information part and we have the next. So this is pretty similar, is it, as what our previous node class defined. And then create a new node. Okay, and then next, let's take a look. This linked list. And for this linked list, because it implements a list interface, is it? And this linked list, it's a concrete class. Because it's concrete class, so you must implement all abstract methods in MyList interface. And if we do one by one check, we will see it does implement all of the method. So anyway, so here we have the constructor empty one, and over here I create with an array of methods. So over here, if you see, it just call the add method. And because this is, let's take a look, that add method, add, we just call add. Oh, that add method, let's take a look back of the list. So in the MyList interface, why I can call that add method? If you recall, that add method call what? Call the abstract that add method with index. But this one is already implemented. That's why, not this one. That's why over here, that add method, because over here, basically it call the default method. Is it the default method add in list, in that MyList interface? But anyway, that add will go ahead call the other add with index and item. Is it the other one? And then let's see, did we implement that add method specific? Not add first, not add last. Okay. Here, did you see we did implement that corresponding abstract add method with the specified index and item? Is it? And over here, say, oh, if you want to add at the beginning or add at the end, is it? And over here, it's insert in the middle. So this is pretty similar as what we learned before in LinkedList. Okay, so this is how we implement this add method. And then we have also the corresponding add first, add last. And add first, add last, this is not from the list. I don't think, I need to double check. I don't think it's from the MyList interface. This is specific to this MyLinkedList method itself. Is it? So what it does, if you take a look, you will find, okay, to create a new node, is it? And then it is specific because you're going to add it to the beginning. So that's why over here, you need to set the first node to this new node and the new node next to the previous header, is it? And if here it says, if the new node is the only node in the list, then you also need to take care of the tail, because in this case, we have both front node and back node. So that's how this part works. And similar for the add last. And the add method we implement, remove first, remove last, it's similar, and the remove method, this one we override. We have override because we override from what? From that MyList interface. Okay, so that's the concept here. And the toString you override, and the clear you override, and the contain method, and then we also override from the MyList interface, and the get method override. So over here, all of this override, what we did is to what? To implement those abstract methods in that MyList interface. Okay, so then this class, so I'm not going to go over the detail of the code. So I believe right now you can read this code on your own. Okay, so it's understandable. And so this is a concrete linked list. So now you can kind of see the idea regarding Java collection, the hierarchy, why we have those super interface and then super interface and then the concrete class. So that's the idea. And the last is just the driver part. We test our own linked list, okay, with a string and test each of the individual methods. Okay, so that's this example about the Java collection.